Hello, welcome back. Let us learn about amplitude shift keying. That is one of the digital to analog conversion in data communication. In amplitude shift keying, the amplitude of the carrier signal is varied to create signal elements, while both frequency and phase remain constant. Frequency and phase remain constant. In amplitude shift keying, only amplitude varies. Now let us see the bandwidth formula for ASK. B is equal to bracket 1 plus D into S, where D is a constant which varies from 0 to 1, and where D equals to 1 will be the worst case and D equals to 0 will be the best case. Now this is the diagrammatic representation of binary amplitude shift keying. As you can see from this diagram, here one signal element is represented by 1 bit. This is 1 bit. And in binary amplitude shift keying, this 1 bit is represented by a voltage fluctuation in the amplitude. As you can see from here, it is fluctuating. And 0 is represented in such a way that we have a flat line on the amplitude. Likewise, 1 is represented by voltage fluctuation or a sine wave, and 0 by a flat line, another one by a sine wave, another one by a sine wave, and 0 by a flat line again. That means 1 bit is represented by one signal element. That means R will be equals to 1. Okay, this is the representation of a bandwidth. The carrier frequency will lies exactly at the middle of the bandwidth. Alright, in amplitude shift keying, R is equals to 1, S is equals to N, B is equals to 1 plus D into S. Why S is equal to N? Let us try to understand this a bit. We know that S is equals to C N by R from the previous formula that we calculated. Here R is equals to 1, as we can see from here, and C is equals to 1 because it is in digital to analog conversion. And when we substitute the value of R and C, that is S will be equals to 1 into N by R, which is 1. That means S will be equals to N. Alright, so we have S equals to N. So how do we implement a binary ASK is that we have a binary digit 1 0 1 1 0. This is represented in binary signal like this. 1 is represented by voltage increase, 0 is represented by flat line, 1 is and another one is represented by voltage up, and 0 is represented by 0 voltage. Okay, so how do we represent this binary signal into analog signal is that we need to have a carrier signal. Here is your carrier signal with a constant frequency. So when we have a multiplier here, this is your binary signal and this is your carrier signal FC with a constant frequency, and then we have a multiplier. When we multiply this, we have a analog signal which represents the binary signal. Okay, so here this is exactly similar as the carrier frequency, but when there is low voltage, we will have a low voltage in the analog signal as well. So when we have a high voltage, we have a modulated signal here with a high voltage representing with the carrier signal, and then when the voltage is low, when the binary is 0, we will have a flat line here. Okay, this is how binary ASK is implemented. Now let us give an example. We have an available bandwidth of 100 kHz which spans from 200 to 300 kHz. What are the number 1, the carrier frequency, And number 2, the bit rate. If we modulated our data by using binary ASK with d equals to 1, first let us see the carrier frequency. Okay, so we have a bandwidth between 200 and 300 kilohertz. This is your bandwidth. The carrier frequency will lies exactly at the middle of the bandwidth. Okay, so here we will have FC, which will be 250 kilohertz. Alright, and the bandwidth will be spanning from the lowest hertz to the highest hertz, which is 100 kilohertz. This particular one is the case of half duplex. Now let's see the case of full duplex communication. We have a frequency between 200 and 300. So in this case, when it is full duplex, it will be divided into two. Here we will have 250 here. One is for transmission and one is for receiver. So in case of full duplex, the bandwidth will be divided into two, 50 kilohertz for transmission and 50 kilohertz for listening, this part for listening, and then one carrier frequency for transmission and one carrier frequency for listening. So in the middle of this we will have FC1 and FC2. FC1 will be of 225 kilohertz and FC2 will be of 275 kilohertz. Okay, now we find out the carrier frequency for this example for half duplex. For half duplex communication, carrier frequency FC is equals to 250 kilohertz. For full duplex, carrier frequency will be of two types. FC1 will be of 225 kilohertz and FC2 will be of 275 kilohertz. Now the second point, we will have to find the bit rate. Alright, as we know before, S is equals to N. We will remember that. And in case of binary ASK, R is equals to 1 because one bit is represented by one signal. So we will take the bandwidth formula. B is equals to 1 plus D and S. Here we know that B is equals to 100 kilohertz. This is your bandwidth, 100 kilohertz, and D is 1. This is the worst case. And then we have S, which is equals to N. Alright, so N is equals to 100 divided by 200 kilohertz divided by 2, and then we will have N equals to 50 bits per second. This will be your data rate. Alright, here N equals to 50, sorry, it will be kilobits per second. 50 kilobits per second is your answer.